So this time we are discussing impact test. Impact test means what we measure here, toughness. What is toughness? Total energy until failure. Again, this term is very important. It is in your quiz. Total energy until failure. You can remember that when I discussed this one, stress state diagram of mild steel, I said that okay, this entire part is called toughness. This entire energy, the entire energy is called toughness. We measure the entire energy of a material using impact test. But again, something to tell you, it is not so accurate. Why not so accurate? I will discuss it. Before discussing, let us do some dynamics. I know that you did not take that part in your, maybe you did not take dynamics class before until today, but no problem, I'll go very slow. Before starting, let us assume a pendulum. I know that you know what is pendulum. I believe you know that. So if I raise it, say here, and then release it, it will go this way. So it will go that way and come back this way. I think now you understood what I mean, pendulum. Some wall clock in your house might have this kind of second leg. So it goes left, right, and then that is every left and right is 1 second. But I believe that you understood this, what I mean. Now, when my pendulum is here, so that is my say reference line. Reference line. If I raise my pendulum and let it go, it will come back. So if I raise even more, it will come back more. Why it will come back? The reason is when I am raising it, it is gaining some energy. That energy is called potential energy. Now you will understand more when you will do dynamics class. So for now, let just like accept this, that or apply common sense. If I raise a stone on top of your head and let it fall, it will fall. That why it will fall? Because it gains some energy. That energy is typically measured by uh, okay, weight times height. This is the energy. Weight times height. Whatever the weight of the material times whatever the height you are raising it. So that is very simplest form. Okay, now, so what is this weight times height? It is the energy. Energy. E means energy here. Okay, now, so let me, okay, now, say let me take a new color. Say I raised up my stone or bob, we call bob. That small piece we call bob. If we raise the bob here and let it go, and you will agree that it will come this way, and it will come here at the same level of the original. Ideally, it should be at the same level, but in real life, it will not be. Why? Because there might be some small air resistance. When it will go here to here, your air will resist it little bit, not so much. Then when it will come here to here, there is some gravity. Your gravity will also pull. So in Newton's law, ideally there is no gravity and there is no air resistance. Even there is some mechanical resistance here. If it is not lubricated well, then there will be some mechanical resistance also. So these three reasons, this is why it is called, it is not so accurate. So there is some resistance which we do not take care. Now, but maybe it was supposed to be here, but maybe it will come here. So that is that small error. But a small error, it is okay because we know that there is error, so we will be safe. That is, but that error, when you do this test, we do not count this error because it is very small and it is only one cycle. As it is only one cycle, even not one cycle, half cycle. I'm raising here, let it go. Here to here is only half. If it goes back, then it becomes 1. So the error is very small. So forget the error now. So hopefully you understood that if it is here, it is supposed to be here. If I let it go, small error, forget it. Now what is happening? So in this test, there is a bob, big bob. We raise it here, place it here, and let it go. It was supposed to be. If you let it go, it will go. Supposed to be here. Now hopefully you understood this part. For now, we are ignoring the small error. Forget the error now. Now, so I am drawing one more case. What happens? That is my bob is here. It is supposed to be go to the same level. It is supposed to be there if I let it go. But if I place something here, if I place a sample here, then what will happen? Say this is a steel beam, a small steel beam. Then what will have happened? You can guess that what I mean. That if I place some beam here and if I raise the bob and then let it fall, what will happen? It will not go to original position. It will come somewhere here. Why? Because when it will go here, this bob must need to break it or must need to overcome this. Then it will lose some energy. Then finally it will come here. Now how much energy is lost to break it? That is this portion. The energy in this portion. That is weight times delta H, the difference. So this portion is the energy of this material to fail. And if the material doesn't fail, the bob will be stuck here. That means the energy of the material is more than the energy here. In that case, we need a larger bob, larger height. But for now, whatever bob we will take, and our sample is very small, so that it will fail. But the amount of height that it did not go, it is the energy of that material. So we measure this. So now hopefully you understood what is impact test. Now small error, we forget it because there's a reason we forget it. In this test, we are not concerned about the energy. We are concerned about something else. Before starting that, let me give you an example of Titanic. I know that you saw that movie, Titanic. You saw that movie, the Titanic ship. It failed 1910 most probably. Yes, and they recovered it 1912 or something, something. And the movie was released maybe 1999, something. Okay. Now there's something to learn from the Titanic. So when they built the Titanic, they tested the material using this impact test at room temperature. At room temperature. And say they found the energy is 100. Energy is 100. And they thought, oh, this energy is so good to resist anything inside the ocean. But they forgot it that if I decrease my temperature in the like ocean when there was snow, the temperature was say minus 10 degree Fahrenheit, whatever. If the temperature lowers, this energy decreases a lot. They did not know that, so they tested in room temperature, found a very high number, and they were very happy. Even they published in the newspaper that their Titanic will never fail. But they forgot that at low temperature, the toughness, the energy, it decreases a lot. So in this test, mainly we are focused on the temperature. That means, okay, so if I will take a new slide. So in this test, what we do, we tested a defined temperature and plot the energy. Say at a high temperature my energy is very high. If I decrease my temperature, energy decreases. Again decrease temperature, decreases. Again decrease temperature. So this is 0 degree or minus 100 degree. Say minus 100 degree is here. 60 degrees. 60, say here rough value. Then if we measure it, we will get a curve like this. Yeah, as this curve has some error, maybe the actual curve is somewhere here. The actual curve. This is actual curve. Because we measure more, we neglect the air resistance, and this is the tested. But we are not concerned about the exact amount of energy. We are concerned about the temperature. You can see after this temperature or below this temperature, my capacity is decreasing a lot. So we will make sure that this material will not be used whatever the temperature here or in this region is okay. This region is not okay. So that is the main purpose of this test, to find the temperature at which we can use this material. Or if we use this material to a low temperature, we should know that what is its energy. So that is our main target, is the temperature. Energy, this value is not accurate. So we are not concerned about the energy. Even during design, you will see we do not take care of the value of the energy. We just in this test we do the temperature. Okay. So what I am going now, I'm going to a handout now, and I'll show you everything. Okay, so at the beginning, so there are two types of test. One is Sharpie, one is IZOT. Sharpie uses a simple beam. IZOT uses a cantilever beam. Now, what is simple beam? What is cantilever beam? I know that you know simple beam is this. Cantilever beam is this. I believe that you know it. So now, what is that? Where I am? Suddenly I got lost. Oh, this is the attendance. Okay, so what is simple energy? So when I raised my so this is my pendulum. When I raised it, if I placed my beam this way, then it will hit this that way. So that is called cantilever beam. Cantilever beam. And this test is called IZOT. IZOT developed this test, so we call IZOT test, cantilever beam. On the other hand, we can place our beam as a simply supported. Say one support here, other support here, place the beam here, and then raise the hammer or bob, then hit it. So this beam, you can see it is simply supported because it has two support on the both side. So it is a simply supported, it is a cantilever beam. So we can place both way. As I know that now you can say maybe this here energy higher, here energy is lower. We are not concerned about the energy, we are concerned about temperature. Whatever test we do for all of our samples, we'll do the same thing. So it doesn't matter, everybody will get the same treatment. Okay, so hopefully understood what is cantilever, what is IZOT. Now you can see the testing equipment. Here we place it. Here we place the beam. In our lab we do Sharpie. That means simply supported beam. We place the beam here and we make a group, somewhere group, so that my material fails here. Now then this is the hammer. We raised it up, and then this is the scale. This is scale placed at high value, say 0 to 100. This is scale 0 to 100. After I let it fall, it will come here, break it, then go up. Then this leg will come here to here. Whatever it came, that is the energy this material took. So that is the test. We will do this test. And this hammer, I forgot the weight, but it is heavy, about 50-60 pound roughly. I forgot it. Yeah, the ASTM, they have their own specification that what to do. Now we mainly do this test at 40 degrees Celsius, 4 degree, -18, -40. Now in minus, how to attain this minus? Yeah, we make a alcohol bath and we can decrease the temperature of alcohol. Other question, why alcohol? Because if you take water at 0 degree, it will be freeze. So if I take alcohol, it doesn't freeze at, I don't know, several hundred Celsius. So this is why we use alcohol. Even this is why in winter, if it is very cold outside, when people work outside, they drink some alcohol. But again, alcohol is not legal in Bible or any religion. I am not expert, just to give. Okay, so hopefully you understood why they use alcohol, because it doesn't freeze at very low temperature. That is why we now how to, other question, how to place a alcohol bath here. It's very difficult. No, what we do, we take this mold and the sample, place it inside a alcohol bath. When we do the test, we bring it back very quickly, place it and do that test. So this way we do it. Now, when we bring the sample from alcohol bath, place it here, it will lose some coldness. The temperature will increase. Yes, true. And it will happen to all the samples. So it is now okay. Why okay? Because if I draw the curve, energy versus temperature is something like this. Maybe the curve is this. Say accurate curve is this. We are doing this one. No problem. We are concerned about the temperature only, the transition temperature. This is the transition temperature where my energy is like changing a lot. So we are not concerned about the exact energy. This is why if every sample get the same treatment, no problem. Okay, so hopefully you understood, and you understood what we do, and you understood like what is our target. You can see this is a the curve of this after the testing. At low temperature, energy is very less. High temperature, energy is very high. Also at high temperature, the material breaks in ductile mode. Ductile mode means it absorbs a lot of energy. It will bend a lot. But here, failure is brittle. That means similar to glass. If you break a glass, it doesn't show anything and it becomes pieces. So the sample becomes pieces here. But here, the sample gets stick with the, maybe my photo will show you. Oh, it is already pieces. So this failure I will call brittle failure. Totally fail. But if it is ductile, they will be attached, but there will be like twisting angle, that kind of failure. So they will be stick with each other. Mainly, yes. Okay, now hopefully you understood this. And let me see. I do not think there's anything else. Oh, there not, and not anything else. Now what I will do, I will show you some photo, no video that I did last year. Mm, okay, who is on? Very difficult question. Okay, let us start with this one. Oh, okay, turning up the sound.
It's going to be like a physical education lab, right?
Okay, what this gentleman is doing? He is raising the hammer and place it on the top, and then he will lock it. We can lock it using this. So see carefully. See locked. Yeah, see locked.
So this is kind of like a, you didn't realize that this lab was going to be
Then
like
he
a
is taking
physical
a
education lab, right?
he is taking
Where you
a
put like
sample,
weights.
and see he placed the sample as a cantilever. Sorry, simply supported beam. See, this is the beam. This and this one are the two support. There's groove on the other side. The hammer will hit here and break it. And so Now you can say, yep, there is a group. So what is the energy? Actually, we are measuring the energy on this group section, and every sample is getting the same treatment, so no problem. So he placed the sample, then he will let, yeah, the scale is on the 300 more full. Yeah, I could not see. That means high level, and he let it go. And you can see that and you saw that after failure, mm, oh, yes,
maximum
300 maximum. Let it fall, break it, yes. Then it came to roughly here. See, this failure is
It actually
ductile failure.
absorbed more energy than the annealed one.
Uh,
204 and a half, almost a 5.
205. Yes. So that is the energy. But if you see the sample did not totally is this sample. It did not make, yes, you can see both sides is stick with each other. The reason is it is a ductile failure. The test was done in a room temperature. So room temperature mainly ductile. So you saw it is a ductile failure. See?
It actually absorbed more energy
Yes.
than the annealed one.
Yeah, what Paul told that it absorbs more energy. Yes, why? Because this test was done in room temperature. Okay, so if I randomly play other samples, say other test, somebody else is taking up, lock it, and then he is taking a specimen,
Did not facing that direction.
placing it that way, group on the other side,
I like to take risks.
and then scale is high, let it fall, and then break it. This button is for break. Yeah, this button is to stop this hammer. Otherwise, we are done. If we let it like do going up and down, there might be some accident. So we stop it by applying the brake. Now you can see it came back to original. So different, when you test it, we test different kinds of specimen, aluminum, steel, to see their energy, just as a practice. Okay, so